Good morning, this is Mrs. Williams here to do a little review of volume and surface area. We're starting with area of a figure in nearest hundredths when we need to round. The first shape that we have is a parallelogram, and with a parallelogram, we need to use the formula base times height, and the base and height must be perpendicular to one another. So you need to look for the right angle box and get the base, so one of the sides of our parallelogram, and a height which is perpendicular to that base. So we do not use the 4.4, it's not perpendicular to our base. Okay, so we are going to multiply 10.8 inches times 3.7 inches. And we get 39.96 inches squared, or square inches. Here we have a circle, and we've done circles recently. We are given the diameter, so the total distance across through the center of the circle. We need the radius for our formula. So that's going to be half of 22, which is 11 meters. Our formula, pi r squared. We're going to use the pi key on our calculator. 11 meters squared. So 11 meters squared would be 121 square meters. We're going to multiply that times pi. So using the pi key on the calculator. And we will have to round this one, so we'll put the curly equal sign. Get 380.13 meters squared, or square meters. Number 3, we have a triangle, and the area of a triangle is 1/2 its base times its height. And again, the base and height must be perpendicular. So look for a right angle symbol. So one of these is the base and one is our height. But we don't know one of those. So I'm going to call that one the base. That can be our height. We do have the hypotenuse. So we're going to use Pythagorean theorem. Call that the C in Pythagorean theorem. And then we'll be able to find this base length. So our base squared plus 16.5 squared, 17.3 squared. And I'll go ahead and square those numbers. Get 272.25. Move this over. I'm going to run off the screen. And 17.3 squared, 299.29. Now I will go ahead and subtract the 272.25. And when I do that, get 27 4/100ths. And then to undo the squaring process, we will square root. So that cancels the square. So it undoes squaring something. And the B is 5.2. So now we know the base of our triangle is 5.2 feet. Now we can use our actual area formula. It's 1/2 or 0.5, 5.2 times 16.5 feet. And we get the area is 42.9 square feet. Number 4, we have a trapezoid. So we have parallel sides here. And I know that because these two links are the same. So for a trapezoid, the area is the average of the two bases. So we have a base 1 here, a second base here. So to average those, I would have to add them together and divide by 2. So add the two bases, divide by 2, or multiply by 1/2. Now I need to know the height of the trapezoid, and that height again has to be perpendicular to our bases, both the bases. So I need to know this height. It would be the same as this height. Imagine that's perpendicular. Okay, and I don't know that. So let's imagine cutting this rectangle out of the middle of this trapezoid. This length would be 7. Okay, that would leave 8 left over for the two triangles. So divide that by 2. So that would give us 4. So 4 plus 7 plus 4 would equal 15. Just cutting that 15 up. So if we're looking on the right at this triangle, the right triangle, okay, I know one leg, I don't know the other leg. That's going to be the height of my trapezoid. But I do know the hypotenuse is the 8.5. So I'm going to use Pythagorean theorem to find this height. All right, so I can do the one leg squared, the 4, plus whatever that other leg, the height is, squared. It's going to be the hypotenuse squared. So go ahead and square those two numbers. And then subtract the 16. And then to undo the square, we will square root. And we get 7.5. So the height is 7.5 millimeters, sorry. All right, so now we know everything that we need. We need one base, we need the second base, and we need the height of the trapezoid. So 7 plus 15 gives us 22, and 1/2 of that is 11. So 11 times 7.5 would be 82.5 millimeters squared, or square millimeters. We're going to skip 5 and 6 for right now. We're going to go to number 7. Not sure where that came from, but there we go. We have a part of a circle, and a part of a circle is called a sector. And for the area of the entire circle, it would be pi r squared. So if we just want some part or some fraction of the circle, we need to figure out that fraction. What part of the circle do we want the area of? We have this shaded area, which is 114 degrees, and the whole circle has 360 degrees. So that gives us the fraction. Of means to multiply. Okay, pi. Our radius we're given is 8 centimeters. Okay, so now I can just use my calculator and get this all multiplied out here, divided out. When you do this fraction, do not round it off. Let your calculator remember that whole decimal. Let me just multiply this out, and we get an area that's approximately 63.67 square centimeters. Next, we have another sector of a circle, but this time we're not given the degrees for the shaded part. We're given the degrees for the white part. So how can we find the degrees of the shaded part? Well, that's easy. We can take 360, which is the whole circle, minus the 37, which is whited out, and we will subtract. So the part that is shaded is 323 degrees. So we will make that fraction 323 degrees out of 360 degrees times the area of the whole circle, which is pi times our radius, which is 15 meters squared. And then we'll just use our handy dandy calculator. Again, do not round anywhere inside this problem. So just let your calculator do all the decimal stuff, and then we'll round at the very end. So we get approximately 634.21 square meters. Next, we're going to, again, be finding area, rounding to the nearest hundredths. And here we have a composite figure. So we've got two shapes put together. We have first a trapezoid on the top, and then we have a triangle on the bottom. So for our trapezoid, remember the area is the average of the bases times the height of that trapezoid. And the height has to be perpendicular to the bases, which we have these perpendicular right angle symbols. So we have a height that's perpendicular. We have base 1 and we have a base 2. So we've got everything we need for the trapezoid. All of that was in meters. Meters. All right, so 7 plus 16, that gives us 23. Divided by 2 is 11.5 or 11 and a half. Both of those are meters. So the area of that trapezoid is 103.5 square meters. I'm going to bubble that so I don't forget about it, because I need to add that with the area of our triangle. I'm just going to erase this stuff I had for the trapezoid right now and just ignore it. Now for a triangle, we need, let me switch colors here for our triangle. Triangle, we need base and height. And the base and height of this triangle must be perpendicular. Well, right now I have an equilateral triangle. I don't have a height that's perpendicular to any of those sides. So what I can do, I'll just choose one of these to be the base. Doesn't really matter which one because they're all the same. So let's just make the 16 the base. We need to know a perpendicular height. So let's just cut this triangle in half here. So we'll cut the 16 in half. That would be 8 on each side. And let's use one of those two right triangles that I've just made The height of the whole triangle would be this length right down through the middle. Either one of these 16s could be the hypotenuse of that right triangle. So let's use Pythagorean theorem to figure out the height. All right, so we can say the height squared plus 8 squared equals 16 squared. 8 squared is 64. 16 squared is 256. And I'll subtract the 64. And then to unsquare, we will square root. Which is going to give me a long decimal, so I'm just going to let my calculator hang on to that. It's about 13.86, but I'm not going to use 13.86 in my problem. I'm actually just going to let my calculator hang on to the long decimal. That's the number that I will use for the height of my triangle. So the base of my triangle is the whole 16 meters. Okay? The height is what I got from the square root of 192. My calculator is remembering it right now for me. So I'm just going to multiply that long decimal times 16 and times 0.5. And I'm getting an area of about 110.85 meters squared. That's the area of the triangle. Now I just need to add those two areas together. The area of my triangle and the area of the trapezoid together is approximately 214 and 35 hundredths square meters. All right, we're going to skip number 10 for now and number 11. We're going to go to number 12. Now we're talking about volume for a few minutes. Volume is the space inside. All right, so if you had little cubes that were each a cubic inch, so an inch on each side of the cube, each edge is an inch long, how many of those cubes would fit in this box? Okay, so our volume is length times width times height. So 8 could be the width, 14 could be the length. So that's the base of this rectangular prism. And the height of our rectangular prism is 23. So we just need to multiply all of those. 14 inches times 8 inches times 23 inches. And we get a volume of 2,576 cubic inches. That's how many little cubes would fit in that box. That's the space inside. Now, surface area is like if we could take this box and unfold it or cut it apart into rectangles, how much area in each rectangle, I'll add it up. Okay, so we have 6 rectangles. Okay, 2 of them, the very bottom and the very top, would be 14 by 8. Okay, so 14 by 8 inches for each one of those, the top and the bottom. 112 square inches. But there's two of them, a bottom and a top. So multiply that by 2. 224 inches squared. I'm kind of box that so I can come back and find it. Now we have like the front of the box and the back of the box. So those are 14 by 23. That's 322 square inches, but there's two of them, a front and a back. 644 square inches. And I'm going to box it so I can come back and find it. And then we have the two skinny sides, the right and the left side, which those are 8 and then 23 tall. So 8 by 23. 184 square inches, and there's two of them. 368 square inches. The area, and then I just need to add all of that together. So 224, 644, and 368. I added that correct. I believe that's right. So 1,236 square inches is the surface area of that rectangular prism. Next, we have a triangular prism. The bases are triangles. And the volume is the area of the base times the height. Now, the bases here are the triangles. So we need to find the area of one of those triangles. So for this triangle, its base, little b, is 9. Its height, perpendicular to its base, is 7.6. Okay, so we're just thinking about the triangle now, not the volume, right? So we're just doing area of this triangle, okay, which is 1/2 its base times its height. So 1/2 of 9 feet times a height of 7.6 feet. And we have 34.2 square feet, the area of one of those triangles. Okay, so that's what we're going to use for the capital B. Now, the height of the prism, I'm going to make this a capital H, I believe, so we can keep it straight from the height of the triangle. Make this a capital H. So the height of the prism is how tall it would be standing if you set it on its triangles, on its base. That would be the 13 feet. Okay. So we'll multiply. And we get a volume of 444.6 cubic feet. So if we had cubes, that were 1 foot on each side, on each edge. That's how many of those cubes would fit in that triangular prism. That's a lot. Now we want surface area. Okay, so let me do a little erasing here on diagram. I need to just do a little bit more marking on it. All right, so imagine unfolding that prism or cutting it apart into its pieces. We have 2 of the triangles. All right, well, we already know one triangle area. We already figured it out. So one triangle is 34.2 feet squared, and we've got 2 of those. So the surface area of the 2 triangles, 68.4 square feet. Now we have 3 rectangles in this prism. Okay, so this rectangle is 9 feet by 13 feet. So this length is 13, this length is 9. Times 9, 117. Then I have a rectangle. Oops, very hard to get here. All right, this rectangle is 8 feet by 13 feet. Which is 104 feet squared. And we have one more rectangle. I think I'm going to have to do a little erasing here to be able to mark it out. This one that is 10 feet by 13 feet. I'm having a hard time tracing these lines here. 10 by 13 is 130. And all of those are feet squared. So we'll add those up. And 51 feet squared in our rectangles. And then so our final total, we'll add the 68.4 with the 351. And we get 419.4 square feet. And that's the total surface area of that prism. All right, now we have a trapezoidal prism. So the bases of this prism would be the trapezoids. Okay? So I will need to find the base area. Because our volume says the area of the base times the height of the prism. Okay, so the height of the prism will be the 21, but I need to find the area of the trapezoid first. Now, luckily, we're given base here that's 19. We don't know this base. Yes, we do. It's 24. And we have a perpendicular to both of those bases, which is 8. So that's the little h, the height of my trapezoid. We have base 1, 24 is our base 2, So the area of our base, the trapezoid, area of our trapezoid, add the bases, multiply it by 1/2 or divide by 2, and then times the height of the trapezoid. So we've got 1/2 times 19 plus 24 times 8, all of that in meters. I believe that comes out to 172 square meters. So that's the area of one of the trapezoids. And which is the big B base of our prism. So area of the trapezoidal base times the height of our prism, which is 21 meters. And our volume is 3,612 cubic meters. Now for the surface area of our trapezoid, we have 2 of the trapezoids. So we already knew the area of the trapezoid. We just need to multiply it by 2. Get 344 square meters for the 2 trapezoids. Kind of bubble that so I can find it later. Now, let me do a little erasing on my picture so that I can find the rectangles on the sides of this trapezoid prism. So, let's see. I have one rectangle here that's 11 by 21. And I have a rectangle on this side that's 21 by 8. Then I have the front rectangle here that's 19 by this distance. I know that height. That's 21 again, right? So 19 times 21. Now, I've got the big rectangle in the back, so let me erase these 3 so I can see the big rectangle in the back. Which is 24 by 21 right there. So, let's do all that multiplying. Which I believe is 1302. Let me double check that though. Yes, 1,302 square meters. Now let's just add that with the trapezoid areas. And you get a grand total of 1,646 square meters for the surface area of this trapezoidal prism. Now we have a cylinder, like a bottle of hand sanitizer or a can of soda. right? And so volume for our cylinder is again the area of its base times the cylinder's height. Well, the base here is a circle. And the area of a circle is pi r squared. We're given the diameter of this circle. So the radius is going to be half of that. The radius is half of 14, which is 7. So we'll do pi times 7 yards squared. So it's 153.94. If I want to go ahead and round it, we'll just go ahead and round it for right now. Yards squared. I'll come back, I'll need that later. All right. But I'm just going to let my calculator hang on to that whole decimal. Okay. So the area of our base is that long decimal. I'm letting the calculator remember. I'm not erasing it or anything. The height of our prism is 18. So I'm just going to take that number that my calculator's got and multiply it by 19. And now I will actually round. 2,924.82 cubic yards. Now, surface area. We have two of those circles, so a bottom and a top. All right, so we need two of the circle areas. Which is about 307.88 square yards. Plus the circular sides, like the sides of the can of soda. Okay. And for that, okay, so imagine taking the sides of the can, cutting the top and the bottom off, splitting it down the side and unrolling it. We end up with a rectangle. Okay, the height is the height of the can, which is 18 yards. The length of that rectangle is the distance around the can. So that is the circumference of the circle. So 2 pi r, or just pi times diameter, whichever one you want to do. Okay, so that's going to be 2 pi times radius of 7 yards. Okay, so the area of that rectangle is its length, 2 pi times 7 yards times its width, which is 18 yards. And that area comes out to about 791.68 yards squared. That's like the sides of the can. Right, so add that with the area of the circles, and we get a grand total of 1,099.56 square yards. All right, next we have a pyramid. And this pyramid has a square base that's 12 by 12. The volume of pyramid is 1/3 times the base's length and width times the height of the pyramid. All right. So the base's length is 12, the base's width is 12, the pyramid's height is 9.1. We get a volume of 436.8 cubic centimeters. And we're going to skip surface area for now. I just want to hit some of these volume problems. We're going to go to a cone. Now, the volume of a cone is 1/3 the area of its base, so pi r squared, times the cone's height. So we have 1/3 times pi. We know the radius of that base is 9 inches. The height of our cone is 14 inches. We get about 1,187.52 cubic inches. Now let's do a volume of the sphere, so a ball. Volume of a sphere is 4/3 pi r cubed. We have the diameter of that circle, but we need to know just the radius. So it would be half of 22, which would be 11. 4/3 times pi times 11 millimeters to the third. We get approximately 5,575.28 cubic millimeters for the volume. And I believe that's all that we're going to do for right now on this one.